Hello everyone. In this video we're going to talk about using those ideas of linear functions and applying them to word problems. So we have an example where an electric bill is based off your energy used. It costs $103 for 4 kilowatt hours. It also costs $205 for 10 kilowatt hours. We're going to find a linear model for the cost C as a function of kilowatt hours used K. This is the same process as we used before, but instead of using f of x, we're going to be using c of k. So let's first note that our input here is going to be our value of k, our kilowatt hours. Our output, that's going to be c, and in this case, our output is cost in dollars. Those are going to be important to understand as we begin to make interpretations once we have a function. So we're trying to find a linear model for cost as a function of kilowatt hours used K. So instead of f of x, we're going to be using c and k. So we're going to try and write some c equals m times k plus b. We're inputting k in this case instead of x. So a good idea here is to try and identify 2 points like we had done previously or like we were given in our previous video. So in this case, we have the points c of 4 equals 103. When we input 4, we get an output of 103. And we also have the point c of 10 equals 205. When we input 10 kilowatt hours, we get an output of $205. Once we identify the input and output variables in 2 points, the process is the same as when we were using just that original function notation in the previous video. So we're going to start first by finding m. 205 minus 103 is our change in outputs over our change in inputs, 10 minus 4. That gives us 102 over 6. So m, the slope, is going to have a value of 17. So far, c equals 17k plus b. So we can pick either one of those points and find b. Let's pick c of 4 equals 103. That means the cost, the output, is 103 when we input 4. Using some algebra, 103 equals 17 times 4, which is 68 plus b. And if we subtract 68 over, we get that b is 35. So far, the cost, c, equals 17k plus 35. So let's talk about those parts of the function, what they mean. The first part, the first thing we want to interpret is the slope, which is 17. The slope is 17. The slope, or the rate of change, will tell us the change in output we expect when we increase the input by 1. We're outputting dollars and we're inputting kilowatt hours. So this tells me that the cost is going up $17 per hour. So cost is increasing $17 per kilowatt hour. The units for any slope will always be output per input. Let's talk about the vertical intercept now. The vertical intercept in this case is 35. As we previously discussed, the vertical intercept will always be the output if we were to input 0. So essentially, this is just the starting cost if no kilowatt hours are used. So if no kilowatt hours are used, the cost is $17. It's important to note the units of the vertical intercept will always be the same as the units of the output because it is corresponding to an output. So the whole reason to develop these formulas is so that we understand how to plug in a value and get an output. So now if I wanted to know what the cost will be for 20 kilowatt hours, that can be determined. I can plug in 20 for K. The cost equals 17 times 20 plus 35. The cost equals 340 plus 35. So the cost is $375. So I want to give you a head start on your written assignment. And again, as you work through any of these type of problems, it's very important to recognize what is your input and what are the units and what is your output. So we've got a little bit of a unique case here where we're given a number of years in a population of a town. This last sentence is very important. Okay, we're outputting a population in people. So the units of the output are people. The input that we're using here is years since 2000. That's a very important thing to distinguish. So the input is years since 2000. We're trying to write a P as a function of T in this case. So P equals MT plus B. To get our 2 points, remember the input is the year since 2000. So the population of Littletownville in 2010 was 19,384. That's 10 years since 2000. So when we input 10, the output is 19,384. Then we're told that in the year 2014, the population is 21,672. So these would be the 2 points that I would need to use to begin writing this function. I would highly encourage you to refer back to this as a good starting point when you go to start this written assignment.